Good afternoon, ladies and gentlemen. My name is Han Xinjun, Research Associate from Beijing Friendship Hospital Radiology Department in China. It is my great pleasure to be here and get this opportunity to present my current progress in MR liver segmentation by using deep learning technique. The title is Deep Learning Algorithm for Automatic Segmentation, the liver using portal-venous phase magnetic resonance images. And first of all, I have nothing to disclose. Briefly summarize my research background. Segmentation of liver segments is a prerequisite for developing a liver disease CED system, which is essential to precisely localize the focal liver lesions and give accurate assessment of diffuse disease. Based on past literature reviewing, there is still an absence in a fully automatic segmentation tool based on deep learning technique for MR images. The aim of my study is to develop and validate a 3D convolutional neural network model for automatic liver segmentation on MR images. The slide summarizes the model used in this study. Two branches were introduced in the output layer. The upper segments produce the liver boundary, and the other segments is pixel-wise segmentation of the liver segments. The late output serves as a final output, while the previous output helps to produce a better boundary. Both quantitative and clinical evaluations were performed to assess the model. In quantitative evaluation, 4 metrics including dissimilar coefficient, mean surface distance, head drop distance, and volume ratio were used. Clinical evaluation were performed via doctor's visual inspection, and indirect evaluation were performed based on lesion localization. As a result, the quantitative result demonstrates that our method has high accuracy with an average DSC of 90.2%. Good results were also achieved in other metrics. In clinical evaluation, according to clinical expert, our model in this study generated very desirable segmentation images in most cases, and covering a wide range of liver appearance from normal to abnormal, and those figures shows examples of those very successful cases. So as you can see, we can see the very clear boundaries and that contour each segments of the liver, and the segmentation is very precise. And the algorithm can also fail in the proper segmentation, meaning in the cases with very severe vascular problem, and including abnormal vascular roots or vessels that were badly invaded by tumors. And in conclusion, the algorithm used in this study has been proved to be clinically effective in assisting lesion localization. As a result, 93.4% of the lesions were localized in red segments simply by referring to the segmentation results without any human medical interference. It is promising and meaningful to consider technique in this study a practical tool in future automatic lesion detection for liver MR images. Finally, I would like to express the greatest appreciation to this organization for supporting me to do this research. And finally, thanks so much that the ISMRM conference inviting me to do this presentation about my research.